please take out this handout to follow along with the lesson. We're continuing on with our study of probability. In the last lesson, we looked at experimental probability. In this lesson, we're looking at theoretical probability. As I mentioned in the last lesson, there's two ways of looking at probability, two ways to calculate probability. One of them is experimental, the other one is theoretical. And theoretical is probably what you're most used to in dealing with games of chance like rolling dice or pulling cards out of a deck, that kind of a thing. Last time we looked at experimental probability, and that's determined using the results of an experiment or different trials. And the way you calculate it was this: the probability of an event is equal to the number of successful trials divided by the total number of trials. For example, if you're rolling a die 10 times and you get an even number 3 times, we would say the probability of rolling an even number was 3 out of 10. That's the experimental probability. Theoretical probability is different. It's determined using an analysis of all possible outcomes. So instead of looking at what actually happened in trials that you actually rolled the dice, you're looking at what are just the possible outcomes. So to calculate theoretical probability, you take the number of possible successes and divide by the total number of possible outcomes. So for example, when you roll a 6-sided die, there are 6 possible outcomes. You could roll a 1, a 2, a 3, a 4, a 5, or a 6. But if you're looking at the probability of rolling an even number, well, how many even numbers are there? There's a 2, 4, 6. So there's 3 possible successes out of 6 possible outcomes. So we would say the probability of rolling an even number is 3 out of 6, or 1/2, or 50%. That's the difference between theoretical probability and experimental probability. So as I go through the rest of this lesson, I will be referring only to theoretical probability. And as we work through the examples, you're going to see different ways that you can analyze situations to figure out the theoretical probability. So here's the first example. Abe, Bruno, and Cecil have each won a prize from Axe for being smelly. The body sprays Shock, Recovery, and Fever will be randomly assigned to the 3 winners. Use S, R, and F to represent the 3 types of body spray. In the table, record all possible outcomes. So what I mean is we're going to figure out all the possible combinations of how the winnings are going to be distributed. There's 3 different prizes, S, R, and F, and they can be distributed between the 3 winners in a lot of different ways. I'm just going to go through this systematically, so I'll just put the letters in order, S, R, F. So Abe could win Shock, Bruno could win Recovery, Cecil could win Fever. Or I could keep Abe with Shock and then just switch Bruno and Cecil's prizes. Abe could start with Recovery, Bruno could have Shock, Cecil could have Fever. Or we could keep Abe the same and switch the other 2. We could have Abe start with Fever, and there's 2 different ways that could happen for the other guys too. So these are all the possible outcomes for the distribution of the prizes amongst the 3 winners. In fact, you'll see there are 6 different possible outcomes. So now the question is, what is the theoretical probability that Bruno will receive Fever as his prize? Well, we just have to look and see how many of these outcomes involve that situation. Well, Bruno receives Fever in this outcome. He also receives Fever in this outcome. So there are 2 possible successes and 6 possible outcomes. So the theoretical probability that Bruno receives Fever is 2 out of 6. Now, of course, every time you write a fraction, you should put it in lowest terms. So 2 out of 6 reduces to 1 out of 3. So there's a 1 in 3 probability that Bruno will receive Fever. And of course, you can change this to a decimal. 1 divided by 3 is 0.33 repeated, and that turns into 33% approximately. Now, what is the theoretical probability that Bruno will receive fever and Cecil will receive shock? Okay, well, Bruno receives fever in this outcome and in this outcome, but in only this outcome does Cecil receive shock as well. So this is the only possible outcome in which this happens. So the probability that Bruno receives fever and Cecil receives shock is only one possible outcome out of the 6, so 1 out of 6. And 1 divided by 6 is about 0.17, which is 17%. So just remember, the bottom of the fraction is the total number of possible outcomes. In this case, there were 6 possible outcomes. The top number in the fraction is just how many of those outcomes get the desired result. This next example deals with a deck of cards, a standard deck of cards. And if you're not familiar with that, these are all the cards. So there's 4 different suits. There's spades, diamonds, clubs, and hearts. And you have the numbers 2 to 10, and then Jack, Queen, King, and Ace. Jack, Queen, and King are called face cards because if you actually look at the cards, they have a human face on them. The other cards are not face cards. So that's just a little bit of the terminology when you're dealing with cards. Okay, so one card is randomly drawn from a deck of cards. What is the probability of each event? So we're just pulling a card out of a shuffled deck of cards, and we want to know what's the probability that that card is going to be a club. Well, remember, theoretical probability is the total number of possible outcomes on the bottom. How many possible outcomes are there when you pull a card? Well, there's 52 cards if you count them all here. So the fraction is going to be out of 52. Now, how many of those outcomes give you the desired result of a club? Well, here's all the clubs. There's 13 of them. So the probability of drawing a club is 13 out of 52. Now this fraction is not in lowest terms. We can reduce that to 1 out of 4. So there's a 1 out of 4 probability that you'll draw a club, or a 25% chance if you're interested in the percent. Now, what if you pull out a card and you want to know the probability that that card will be a jack? So the probability that the card is a jack is, well, the number of possible successes. How many of these outcomes are jacks? 4 out of the total number of outcomes, which is 52. So the probability of getting a jack is 4 out of 52. And that reduces to 1 out of 13, which is about 7.7%. Okay, what's the probability that the card will be a heart, a club, or a queen? So we're interested in whether it's going to be all 3 of those. So to find the total number of possible successes or successful outcomes, we have to look at how many outcomes are hearts. Well, there's 13 of them. And then we add how many cards are clubs. Well, there's 13 clubs. Then we have to add how many queens there are. Now, don't get tricked. A lot of people are just going to add 4 here. But remember, the Queen of Hearts is already included in the hearts. The Queen of Clubs is already included with the clubs. So you've already counted those queens. How many more queens are there? There's only 2 more queens. So we have 13 hearts plus 13 clubs plus 2 more cards that are queens to get the total number of possible successes out of the 52. So that works out to 28 out of 52. You can think of it as 28 of the 52 cards are hearts, clubs, or queens. Now this fraction is not in lowest terms. That works out to 7 out of 13, which is about 54%. So you have a 54% chance of getting either a heart, a club, or a queen. So I'm going to challenge you to try the last three on your own. Pause the video and see if you can figure out the probability of drawing a red card or a king, the probability of drawing an ace or a face card. Remember what face cards are. Jack, queen, or king. And the probability of drawing a black or a red card. So pause the video, try to figure those out, and then check back in to see how you did. So for the red card or king, I just counted up, well, there's 26 red cards, 13 here and 13 here. And there are 2 more kings. So that gives me 28 out of 52, which is 7 out of 13, 54%. An ace or a face card, well, it's ace, jack, queen, or king. There's 4 aces, 4 jacks, 4 queens, 4 kings. That adds up to 16 possible successes out of the 52 possible outcomes, which reduces to 4 out of 13, which is about 31%. And then here, the probability that it's either black or red, well, there's 26 black cards, 26 red cards. So that's 52 out of 52. That's all the cards. That's 100% probability that your card will be either black or red. Now the last example deals with rolling 2 dice at the same time. And we want to know the probability of rolling a sum of 7, getting doubles, or rolling a sum of a 3 or 11. So we need a way of figuring out what all the possible outcomes are when you're rolling 2 dice. It's not just you can roll either a 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. There's different ways of getting each of those events. So we need to make a chart somehow to figure out what all the possible outcomes are. And so I'm going to show you a chart that I find very helpful when you're dealing with rolling 2 dice. And then you can write it down, put it in your notes, and then you'll have it to refer to. So here it is. And I'll just explain it first. So we're rolling 2 dice. So the first die, you can have a 1, a 2, 3, 4, 5, or 6. The second die, you have the same possible outcomes, 1, 2, 3, 4, 5, or 6. But when we're rolling 2 dice together, we add up the number that's being displayed on each die. So you could roll a 1 and a 1, in which case your outcome would be a 2. You can roll a 2 and a 2, in which case your outcome would be a 4. You add them together. Let's say you rolled a 5 on the first die and a 4 on the second die. Well, 5 and 4, that gives you 9. So that's your possible outcome. So you'll see the possible outcomes are rolling a 2. You can roll a 3 in 2 different ways. You can roll a 4 in 3 different ways. You can roll a 5 in 4 different ways, etc. So if we're looking at what is the probability of rolling a sum of 7, we have to find the total number of possible ways you can roll a 7. There's 6 ways you can get a 7. Now, how many possible outcomes are there? Well, all of these are possible outcomes. So there are 36 possible outcomes when you're rolling 2 dice. So the probability of rolling a 7 is 6 out of 36, or 1/6. And that translates to about 16.7%. Now, what's the probability of rolling doubles? Well, doubles is just getting the same result on each die. So you could roll a 1 and a 1, or 2 and a 2, a 3 and a 3, etc. So there are 6 ways you can get doubles out of the 36 possible outcomes. So this is the same probability as rolling a sum of 7. So these are the possible outcomes that are the most likely. What about rolling a sum of 3 or 11? Either 3 or 11, it doesn't really matter. So we have to do like we did in the cards where it was asking for more than one possible outcome. We just add them up together. So how many outcomes get you a sum of 3? Well, 2 of them. How many outcomes get you an 11? 2 of them. So the probability of rolling a sum of 3 or 11 is 4 out of 36, which reduces to 1 over 9, and that's about 11.1%. So regardless of what the situation is, whether you're looking at the distribution of prizes or a deck of cards or dice, anything, when you're finding theoretical probability, it's always the same calculation. You take the number of ways that thing could happen divided by the total number of possible outcomes. Once you do that, all you have to do is reduce the fraction to lowest terms, and then if you're asked to or if you want to, you can convert that into a decimal and a percent. So hopefully this was helpful. If you have any questions, please let me know and I'll do my best to help. Otherwise, move on to the practice questions.